Hello everyone, this is limiting reactant section in chapter 5. So chapter 5 we are talking about chemical reactions. So you need to identify limiting and the excess reactants in the given chemical reactions. So let's see how we can identify limiting and the excess reactants using the given amounts. First let's see what are the limiting reactants and excess reactants meaning. The limiting reactant is the reactant used or completely consumed in the reaction. Excess reactant is the reactant present in greater than necessary to react. So after the chemical reactions, when reactants combine to give products, the first reactant completely consumed we call limiting. The reactant that remaining even after the reaction we call excess reactant. Let's take an example, making sandwiches. So this is the normal process. So we are making sandwich, 2 slices of bread and 1 slices of cheese. Now let's see what are the available amounts. We have 28 slices of bread and 11 slices of cheese at the beginning. Now you need to figure out how many sandwiches we can make according to this process. 2 slices need 1 cheese slice. Yes, this is your answer. 11 sandwiches we can make and 6 slices of bread remaining as excess at the end of the sandwich making process. Now why we need to limit the sandwich making at this point? The reason is we don't have enough cheese. We have only 11 slices. That means we can make only 11 sandwiches. However, we have more than enough bread. 6 slices remaining. So cheese is our limiting reactant. Because of the cheese, the reaction needs to limit. But bread is our excess. Even at the end of the reaction, the sum of the bread left over. So now you have a great idea about the limiting reactant and the excess reactant. Now let's apply this food analogy to chemical reactions. Question is, which is the limiting reactant when 5.00 grams of hydrogen, that is H2, react with 10.0 grams of O2. After they react, the product should be water, H2O. Now reactants, reaction arrow, products. Let's balance the chemical reaction. So after we add stoichiometric coefficients, it should be 2 moles of H2 react with 1 mole of O2 to produce 2 mole of H2O. Now we need only the reactant side, H2 and O2. So what is the molar ratio between H2 and O2? 2 moles need 1 mole of O2. 2 to 1 is molar ratio. So if 2 moles of H2 need 1 mole, 4 moles of H2 need half of that amount. Always, whatever the amounts of H2 need, the half of that amount of oxygen need to react with H2, because the molar ratio always should be 2 to 1. Now we have a gram quantities given in the question, but we need to convert grams into moles. Why we need to convert grams into moles? The reason is the chemical reactions we need to read in moles. This is 2 moles react with 1 mole of oxygen. So let's convert first grams into moles. This is number of hydrogen moles in 5 grams. Hydrogen, one atom mass is 1 gram, but molecular hydrogen or diatomic hydrogen mass is 2 grams. So if you convert grams into moles, it is 2.50 moles of hydrogen. The same way, number of moles of oxygen in 10 grams. One oxygen atom mass is 16, but oxygen is a diatomic molecule, 2 atoms bonded together. The mass is 32. Then the number of moles, 0.3125 moles. Now these are the available amounts at the beginning. Now we need to match these available amounts according to the ratio, theoretical ratio in the balance equation. So let's combine 2 to 1 ratio using these available amounts. This is the case 1. In case 1, I will think if all H2 moles completely consumed. So how many H2 moles available? 2.5. If I think all H2 moles completely reacted first, then how many moles of oxygen required with that amount? H2 is 2.5, then hydrogen should be 2.5 divided by 2 because molar ratio is 2 to 1. Then 2.50 divided by 2 amount is 1.25. But we don't have 1.25 amounts from oxygen, less than that amount of oxygen available. This is not the case. Then case 1 is not true. Let's go case number 2. Now this time I'm going to think if all oxygen number of moles available completely react. So available oxygen 0.3125. If all 3.3125 reacted, how many moles of H2 required? Molar ratio should be 1 to 2. So if all 0.3125 of oxygen react, double that amount of hydrogen required with that. So 0.3125 we doubles, it is 0.624 something. So that amount we can readily get from hydrogen because we have more than that. So case 2 is true. Then excess reactant should be hydrogen. The limiting reactant is O2. So if you have a a question like this, first you need to think one reactant at a time until you practice, and then you can figure out which one is should be the excess, which one is the limiting. So let's go for another example. Second example, what is the limiting reactant in the reaction produces sodium chloride, that is NaCl, from 6 grams of sodium is a metal, plus diatomic chlorine 6 grams. Chlorine is a gas, it is 6 grams. Now available amounts are 6 grams of sodium and 6 grams of chlorine. The same like previously, let's convert grams into moles first. This is how grams when converted to moles. Sodium molar mass 23, chlorine molar mass 71 or 70.9 exactly. So after we convert into moles, sodium 0.261 moles available, chlorine 0.0846 moles available at the beginning. Now we need to combine the available amounts with the molar ratio given in the balance equation, 2 to 1 again. 2 moles of sodium need 1 moles of chlorine. 4 moles of sodium need 4 divided by 2, 2 moles of chlorine, and so on. Again, the case number 1. So this time I'm going to think all sodium moles available, that is 0.261 completely consumed. So if all 0.261 completely consumed, according to the ratio, the half of that amount of chlorine required. So 0.261 divided by 2 is 0.1305. So we don't have that much chlorine. So this is not the case then. Case number 2. So if all chlorine number of moles, that is 0.0846 completely consumed, number of sodium moles need with that amount is 0.04, double that amount. 0.0846 times 2 amount, but we have more than that sodium available. That means sodium is our excess reactant and chlorine should be our limiting reactant. Completely consumed reactant chlorine, and even after the reaction, some of the sodium is remaining. This is another example for you, but it's not complicated like previous one. Molar amounts given for you, so you don't need to calculate moles using molar masses. So this is the chemical reaction given. 1 mole of N2 react with 1 mole of O2 to produce 2 moles of NO. So initially 3.24 moles of N2 and 1.75 moles of O2 present. And molar ratio you can see 1 to 1. 1 N2 need 1 O2. Now try to argue and then find out which one is excess, which one is limiting. Your answer should be N2 is the excess, O2 is the limiting. I hope you will try this example to understand better the limiting reactant concept. Thank you everyone.